This is an engineering mathematics question based upon sets and relations. We are having a relation R that is created on a set having three elements 1, 2 and 3. And it has been given that suppose a relation is chosen from R at random, which means R is set of all possible relations that can be created out of this set. So from the pool of all those relations, we have to pick up a relation at random and have to find out the probability that the chosen relation is reflexive, which means you will have a pool of relations and from that you will randomly pick up one relation and you have to report the probability of that relation being reflexive. So that is what this question is trying to ask. So how will we proceed for this? We know that it's a simply probability question. We will find out the number of reflexive relations and we will divide that by the number of total relations. That is what will give us the probability of a relation being reflexive. So now we need to find out both of these things independently. So how we'll do that? We have this set with three elements on which the relations are to be formed. So we will consider both the relations A and B made out of the same set having three elements 1, 2 and 3, which means the cardinality of both the sets is also same. Let us call them n. So now first let us find out the total number of relations that can exist between them. So how do we do that basically? What does a relation mean? We will pick up one element from set A and we will map it with one element of set B, and this pair, let us say from A we pick up this small a and from set B we pick up this small b. So this is what gives us a pair, and we will form all such pairs and then from those pairs we create out a relation, which means in our case, if we solve for the general case considering n to be the number of elements, then we will pick up one element from set A and we will pick up one element from set B. So there are total n times n, which is n square. So there are n square possible pairs of elements, and for every such pair we may or we may not include it in a relation, which means every pair has two choices, take or not take, and this is what gives us the total number of relations as 2 raised to the power n squared. This is the total number of relations that will be there in R, which means we have found out the denominator to be 2 raised to n squared. And now coming to the numerator part, that is the number of reflexive relations. How will that be done? First let us understand what is the reflexive relation. We know that relations of the type A related to A is called a reflexive relation, which means the same element must be chosen from both the sets. So for this what we'll do, we will go to set A and we will pick up one element. What is the number of ways of doing so? There are n elements, so n ways. And now coming to set B, we will not have any choice. If you have picked up, let us say 5 from set A, then you will also have to pick up 5 itself from set B, which means there is just a single choice. So this is what n into 1 equal to n gives us the number of reflexive pairs, and hence the number of reflexive relations to be found out would be given by those which are remaining out of this. We know that the property of reflexive relations is that all of these reflexive pairs have to be included for sure, which means let us say you have a relation like 1, 1, 2, 2, 3, 3. These three would be compulsory for this particular question. Other than these three pairs, you can have any other pair that is also allowed, which means for a relation to be reflexive, we have to compulsorily pick up all the reflexive pairs, and for the remaining pairs, you may or you may not take them. It is allowed. So let us find out what is the number of the pairs which are non-reflexive. We know that total number of pairs is n squared, and from that number of reflexive pairs is n. So n squared minus n is the number of non-reflexive pairs. So we may or we may not pick up anything out of them. Hence each of this pair has two choices, pick or not pick, and that gives us a total number of non-reflexive relations to be 2 raised to n squared minus n. For example, here along with these reflexive pairs we can have, let us say, 2, 3, 3, 1, 1, 2, anything is allowed. This will also be called as a reflexive relation. So now, putting it all together, we will say that the number of reflexive relations has to be given as 2 raised to the power n squared minus n. Why so? Because we just saw that for a relation to be reflexive, there is no choice in case of reflexive pairs. They have to be picked up for sure. You can say there is only one way of doing so. So for reflexive pairs, only one way of picking them. But for these non-reflexive pairs, everyone has a choice. We can pick up or not pick up. And the number of such non-reflexive pairs is n squared minus n. And when each one of them is given a choice, that gives us 2 raised to the power n squared minus n ways. This is the number of reflexive relations that we can have. So we got the numerator as well. It is 2 raised to the power n squared minus n. So these are the in general values which you can also use in other questions. So now for this one, the value of n was 3. So let us substitute that and find out the answer. So for this one, the number of reflexive relations is 2 to the power 3 squared minus 3, which means 9 minus 3, 6. And number of total relations is 2 to the power 3 squared, that is 2 to the power 9. So this is 1 by 2 cube or 1 by 8 or 0.125. So this is what gives us the probability for a chosen relation to be reflexive. That is the answer.